Hello guys, today we're gonna talk about declaring arrays. There's two ways in assembly to declare arrays. Today we're gonna take the first one, next lecture we'll take the second, and then we'll explain more about memory. So what we wanna do now is, let's first do the program include by the template include Irvine 32.inc, and now .data .code main process exit main end process and main. So the first way to declare arrays, we can declare them as list. Let's say list byte, the size of each element is a byte, and we can say, let's say 11 hexa, 25, and 1011 0011 binary, and let's put another hexa number, or 0 A 4 hexa. And I did those on purpose. First, this is 11 hexa. A hexadecimal number is 4 bits, and I'm saying a byte, so I have two 4-bit hexadecimal numbers, and those are going to be, if we convert them to binary, 001 and 001. Those are going to be the hexadecimal. For the decimal 25, we represent it N1, and binary we can represent it as 1, 2, 4, 8, 16, and all those are explained in previous lectures if you want to go back and check them. Here's 1 bit, 2 bits, 3 bits, 4 bits, 6, 7, and here's 8. 128, and I have so it's going to be 0, 64 is 0, 32 is 0, and 16 is 1, 8 is 1, that's 24, 0, 0, and this will be my decimal number, and the binary is already there. This is it 3 digits or what is this? Think of it. Always before a letter, if I have the first hexadecimal as a letter, I put an extra 0. That's not in memory. That's just indicating that I have a letter after it as a hexadecimal number. So A is 10, which will be 0, 1, 1, 0, 1, 0. This is A, and the 4 is 1, 0, 0, 1, 0, 0. This is the 4. How many? Now this is my array. I have an array of size 4, meaning 4 elements, each of a byte, and I can declare each one as I want. By default, it takes it as decimal. If I want to indicate it's a hexa, I'll put an H. If I want to indicate it as a binary, I'll put B, and this is hexa. 4 elements. This functionality is not available in C. Or list 1, we can say word. A word is 2 bytes. So let's put 1000 hexa, 2000 hexa, and 3000 hexa. So now I have an array of size 3, and I have list2 as D word, and I can have it, it's gonna be 1 2 3 4 6 7 8 4 bytes. Here's 1 byte, 2 byte, 3 byte, and this is hexa, and let's only have 2 numbers, 2 2 3 3 4 4, and this is 4 bytes. So this is an array of 4 byte size, 4 bytes, 2 elements. An array of size 2, each element is 4 bytes, each element of 4 bytes. This is the first way to declare an array in assembly. We have what's called $sign minus list. And this will give me the size of the array. And this will give me size 2 $sign minus list2. So the first one should give me 4, the second should give me 3. Size 1 is 3, size 2 is 2. So now what's the $sign? And let's go quickly to memory and see how this is written in memory. It's really important, guys, to see how a program is laid out in memory. It helps a lot. Believe me, it helps a lot. Now we had 4 bytes, and then we had 6 bytes, and then we have 8 bytes. 4 bytes, it's gonna be 6 10 and 8 18 rows. So I'm gonna add a table. I'm gonna have 18 rows, and I want to make it 2 columns on purpose, because I want to put in 1 column the address, so you don't get confused by that. And this is a byte addressable memory. A byte addressable memory meaning each byte, this is 1 byte, 8-bit, has an address. This is the address. And let's say we start with the address. Usually you'll see addresses looking like this, 0x, and let's start with address 1100. And this is the $sign. The $sign is called the current location pointer. The current location pointer, where it's pointing at memory right now. When I'm here, still I haven't went into the memory, it's pointing at the first address. When I finished those 4 bytes, it's gonna be at list 1, and this is gonna be named, we can name it as list, and I have 1 hexa, so it's gonna take 0 0. This is in hexa, this is the first byte. Then we had a 25 in decimal, it was 001, or let's start from that side. I can remember it this way. And here 4, this is the 25, decimal. Then we had, what did we have? 1 1. Then we had the binary number, which was what? Okay, so this is the 11 hex of the first, second, and each is 1 byte. And now this, then I have for, oh no, 100000011, and now I have the A, which is 10, and 4, which is 0100. This is list. This is list plus 0, and this address is list plus 1. Y, each is 1 byte, and this is list plus 2, list plus 3, and it's gonna be, this one is gonna be what? Be careful, those you only need one of them, but I put them both just to make it easier for you to understand it. This is what? 1001. And what's this gonna be? 1002. And what's this gonna be? 1003. I prefer knowing it as list 1, list plus 0, list plus 1, list plus 2. The compiler deals with this, you deal with those. It's really good to understand what's going on in memory, guys. Now we have address 0x1004, and after we finish doing, after it runs this, it's gonna go check size. Size 1, what does it equal? Current location pointer minus list. What's the current location pointer? It's gonna be an address. So if I go to memory, this is gonna be here the current location pointer after list. So it's gonna be, so size, can I put, so here's what size is gonna be. Size is gonna be, it's gonna equal what? Current location pointer 104 minus 11, or 10, sorry. List is 10. So what is it gonna be? It's gonna be 4. So size is gonna equal to 4. I'm sorry I did it that way, I just want to show you what's going on. Size is gonna be 4. Here, calculating this, size is gonna be 4. Now we do this, a word. We have list 1 as a word, and it's gonna start filling in the current location pointer. List 1 is a word, so here I'll have list 1 plus 1. Let's move it a little bit, so, and this is because it's a word, it's gonna take two elements. Those are gonna be, let's say, list 1, or list 1 plus 0. Sorry guys, this is 105, so this address is gonna be what? 0x106, and list 1 plus 1, and it's gonna have the second element, and this is gonna be 0x108, list 1 plus 2, the third element. And let's give it, I didn't give this because I Let's give this another color. Let's make it yellow. I just want to show the differences. So now what do we have in them as data? So I have 1000 hexa, 2000 hexa, 3000 hexa. Now it's really important. So I'm saying 1000 hexa. 1000 hexa. This is each is 1 byte. So I'm gonna have here 1 byte and here 1 byte. Does it do it this way or does it do it this way? Which one? This is what's called Little Endian and Big Endian. Little Endian and Big Endian. Little Endian. What does Little Endian mean? Meaning the least significant byte. Least significant byte. What do I mean by the least significant byte? The byte with the lowest value. This is the byte with the lowest value. Why? Think of them. If you convert this to binary, what is it gonna be? Let's have it here. I'm just showing it. So I'm gonna have 0 0 0 0. This is the first 0 representing this, and then I have the second 0 0 0 0, and then I have the third 0. Then I have what? The 1. And what happens here, this is going to be equal what? 2 to the power 0 is 1. 2 to the power 1 is 2. 4, 8, 16, 32, 64, 128, 256, 512. So the lowest significant bit is this. So what's the lowest significant byte? It's this one. Lowest, or this one. Lowest significant byte at the lowest address. Lowest significant. This is Little Endian. Lowest significant byte at the lowest address. So this will be Little Endian, the one on the right, the 0 0 and 1 0. This and this will be Little Endian. If I saved it this way, it'll be Big Endian. So Little Endian, Big Endian, why is it? It's the way we store it in memory. If I have more than 1 byte. Here, there was no problem. There's no Little Endian, Big Endian. Why? My memory is 1 byte. Byte addressable memory. So, and each element is 1 byte. I don't need to worry about that. Each element will take a byte. Here, no. I have one element that takes 2 memory locations. 2 bytes. So, the lowest significant byte will take the lowest address. And this is Little Endian. So, this is the way that it will be saved. Meaning what? 0 0 0. And here we have 3 zeros. What about this? This will be, this is in binary. This is how it will save it in binary. What about the second element? What do we have? Second element is 2000 hexa. Least significant byte at the lowest address. Least significant byte at the lowest address. So think of it here. Now I'm going to put it in hexa. I'm not going to put it in binary. And this is the way it saves it. But it saves it as one element. And here we have 3000, least significant bit at the lowest byte at the lowest address. And here we have 30 hexa. Good. Now what about, now I'm going to start with 0x 1 1 0 0 or 10. And we're going to have list 2 plus 0. How many? Now, before that, let's go to the size now. I need to calculate the size of what? Size 1 equals $sign minus list 1. List 1, where is list 1? List 1 is here. So it's going to be 104. Let's draw here another one. Let's put it here. 104, that's list 1, dollar sign, or no, sorry, that's list 1. What about the dollar sign? The dollar sign is going to be current location pointer. I filled this memory location. Now where's my current location pointer pointing at? The first empty or available address after I fill list 1, which is 101 minus what? List 1, which is 1004. So what size 1? It's gonna be 6. How many bytes does this take? 6. What's the size of array 2? Is it 6? No, it's in byte. It's 6. But because it's a word, we can do what? To see how many elements, we divide it by 2. A word, we divide by 2. Here, we don't divide it, it's a byte. It's like saying divide it by 1. Here, because it's a word, I divide by 2. It will give me the size of the element. If I didn't divide in 2, it will give me the size in bytes. So now let's go to list 2. Here, I'm going to have list 2 plus 1. List 2, each element is what? Each element is a D word, meaning 4 bytes. And I have 1, 2, 3, 4, 5, 6, 7, 8. Let's go back here. Here's a byte. Here's 2. Here's 3. Here's 4 bytes. And little Endian, what does it say? Lowest significant byte, which is 7, 8 as the lowest address. 5, 6. And 3, 4. And 1, 2. This is the first element, which is list 2 plus 0. Now here, what will I have? Address 10, 1, 1. Usually addresses are in hexadecimal, but I'm showing you numbers so you can understand. 1, 4, 0, 1, 2, 3, 4. And it is going to be list 2 plus what? 4. This is, sorry guys, my bad. This is 2. And this is 4. It's on the number of bytes. It's not the elements. 0. And here 4. And this will be what? I have 1, 1, 2, 2, 3, 3, 4, 4. What's the lowest significant byte? It's this. Little Endian. This is the second one. 4, 4 hexa. 3, 3 hexa. And 2, 2 hexa. And 1, 1 hexa. Now let's go to calculating what? Size 2, which is saying what? And I'm going to put it all here so you can see it. We're going to have size 2 equals current location pointer minus list 2. This is to find the size of array of list 2. And here it is. No, I didn't put an equal here. What's the current location pointer? Now, what's the current location pointer? Remember, current location pointer, first empty memory space is gonna be what? This is 15, 16, 17. It's gonna be pointing here. This element, whatever I have here, and this. After that, 118. So it's gonna be current location pointer is gonna be what? One 018 minus list 2. What's list 2? It's 1, or it's 1 0 1 0, and it equals 8. 8 in what? 8 bytes. To find the size of the array, what do I want to do? I'll divide by what? We divided by 2 on a word, we divided by 1 on a byte, we divide by 4 on a D word. So 8 divided by 4, it's gonna give me what? 2 elements, which is the size of the array. The size of the array. So now let's go and do some calculations. Let's put EAX equals 0. Okay. Oh, I'm writing C now. Move EAX 0. And what do you want to do? Let's move list. Okay, move list to what? To AL, and move A high. I want to move lists plus 1, or which one? Let's move this, because in this I'm gonna move those. I'm gonna move this to AL and this to AH, but now let's put 3. So I'll move what? 11 hexa and 04H hexa, and here we'll do call dump register, and let's move to BX 1 byte. I'm gonna move, let's move this one. Yeah, oh, what is it? List 1 plus 1 plus 2, because 0 1 plus 0 and plus 1 are for this, plus 2 and plus 3 are for this, plus 4 and plus 5 is for this. And let's do call dump register, and now let's move to ECX I want to move EBX 0, and let's do a call dump register here just to show you what. This will call all the registers to see what is in the registers. Call all the registers to see what is in the registers, and let's do here EAX because we already have it at 0. I want to move the second element, which is what? List 2 plus 4. Go back to this memory. List 2 plus 4, meaning all of those 4 bytes. I had list 1 plus 2, meaning I'm gonna move this byte. I had this list and list plus 3, I'm moving those. So let's go back to our code. Those you can do the same. We can move it to whatever we want, and then print it, but we need to give it the size. So now it's might give us an error. Let's check file, save as, declare array .asm. Really important, guys. Okay, let's run. Check any errors. Error syntax, error size. Okay, I didn't like size, so size byte equals save it, compile, syntax error size. What is wrong with it? What could be the error? So here's the message. It's saying error syntax error. Okay, it's the I want to show you. It's saying size. We can't use size. We can't name it size 1, size 2. Sorry, so I did something wrong here. Okay, no, I did something wrong here. Oh, we don't need the bytes. Yeah, we can do it this way. And let's still put size 3. This won't matter. Now I think it should work. Okay. Now error is good. And here we go. How many dumb registers we have? Only 3. 1, 2, 3. I didn't have one here. I should have had one here, but anyway, EAX, EVX 00, and it's showing us both of them zeros. I don't know if you can see the other EVX. This is the first 2 lines we did here, and I call them registers. Now we are moving list to AL, and move list plus 3 to AH. List plus 3 is what? This one, and list is this. So we're moving 11H. Here we go, and A4 to AL. This is AL, this is AH, and all of this is EAX. And now we have move AH no column register. Now here I'm moving BX. I'm moving list 2 to BX. List 2 is 2000 hex, and that should take to AX, override it with the new value of, and let's add it here. Let's do call dump register and show you how it changes. And let's close this. Ran without any errors. And you should see it here. 1 1 2 2 3 4. It overwrote this. Why? Because I'm saying move list 2 plus 4, which is what? 1 1 2 2 3 3 4 4 to EAX. Remember, size matter. The others, don't worry about those. Those are what? Just extra number, extra values that are going to be there depending on the registers. Depending on the registers. So now let's stop here, and for the next example I'm gonna use this and show you just to change some simple modifications, and we go from there. Thank you guys.